A very warm welcome in the course of numerical methods. We are in the module of solution of system of linear equations. In this module, we have already discussed that we are going to discuss direct methods and iterative methods. In direct method, in the last section of discussion, we have already introduced the matrix factorization. To be specific, the matrix factorization in terms of lower and upper triangular matrix is discussed along with examples. In this particular lecture, we are going to see that how that particular factorization technique helps us to finding out the solution of the system of linear equations. So let us start this thing. If we have one system of linear equation and if I represent it in the form of Ax is equal to B form, where A is now for us a square matrix, then we are now confident in that we can represent it in terms of A is equal to L and U, where L is the lower triangular matrix and U is the upper triangular matrix. We know the definitions of lower triangular matrix and upper triangular matrix, and we also know how to find out this factorization. So in the next line we can write it as L U X is equal to B. Now just for our initial understanding purpose, if we consider A is a square matrix of 3 cross 3 order, then L is also going to be a square matrix of 3 cross 3 order and U is also going to be a square matrix of 3 cross 3 order. So what we get, instead of A, if I write LUX is equal to B, according to our problem structure, the total number of unknown variables is 3 and it is represented in a column matrix form. So we can write it as it is a 3 cross 1. So now you please check the consideration of U and X, where U is one of my 3 cross 3 matrix and X is my 3 cross 1 matrix. So their product will give you one matrix which must be a 3 cross 1 matrix. And in this case, suppose we are assuming it as capital Y. So capital Y is my resulting matrix of U and X, which is going to be a 3 cross 1 matrix. So in the next line we can write it as Ly is equal to B. For the consistency checking, what we can get, that is Ly, if I write it and as L is also a 3 cross 3 matrix, and we get from the generation of Y that Y is going to be a 3 cross 1 matrix, the result of Ly must be a 3 cross 1 matrix. Now we see that from this structure Ly is equal to B and B is given to us. We know that B is a 3 cross 1 matrix. So what I am trying to say, Ly, according to this assumption point of view, it is going to be a 3 cross 1 matrix, and from this structure also we get that Ly is equal to B, where B is also a 3 cross 1 matrix. That means this assumption and this system is consistent. Now one very important information I want to share to you. After getting Ly is equal to B, we can find out from this system the value of Y, though Y is a column matrix of 3 cross 1 type, but we will get the value of Y, and if we get the value of Y, we can put it in the equation what we got as, or what we assumed over here, that is ux is equal to y. Putting the value of y here, we can get in the next line the value of x, because u is known and y is also now known to us, so we can find out x. Now can you recall that x is nothing but your x1, x2, x3, this column matrix is not this transpose, so we can just, for writing the purpose, we are writing it in this manner. It is a column matrix x1, x2, x3, and we will get my final target achieved. So this is the basic theoretical part behind this matrix factorization and the application of matrix factorization in the solving of system of linear equation. Now in the next slide we are going to check that how it works. So suppose my system of linear equation is like that. So apparently there is no such problem in this particular given system of linear equations. We are having three unknowns and we are having three equations over here, so it is a square system, and here my unknowns are represented as x1, x2, x3, and the constants what we are getting as 8, 15 and again 8. So we are now going to check that what is my matrix A here. In this context, I can write it as Ax is equal to B, where my capital A is, yes, I know all of you can identify, 2 minus 3 and 4, then 1, 1, 4, and then 3, 4 minus 1. And here my target is to factorize it in A is equal to LU, where for this particular problem I am assuming my L as, you know that we can take it into two ways, but here we are taking this L. You can obviously do the problem in the different manner. So here we are taking my L as L11 0 0, L21 L22 0, L31 L32 L33, and my capital U is, obviously now you are very comfortable with this concept that my U will be 1, U12, U13, then 0 1, U23 and 0 0 1. So now if you want to factorize it according to the previous lectures process, you can factorize it, and I think if you go back and compare, you see that already this matrix is factorized by us and we get our L and our U. So what L we got my L as in the previous calculation, putting the values of L11, L22, etc., we get my L as 2, 0, 0, 1, 5 by 2, 0, and 3, then 17 by 2 and minus 69 by 5. It was my L, and you got the U as 1 minus 3 by 2, then 2, then 0, 1, 4 by 5, and 0, 0, 1. All these are calculated in the last video or the last lecture. Okay. Now I think you can now recall that the previous slide what we have written, we have taken A is equal to LU, X is equal to B, and we have assumed that our UX is equal to Y, so LY is equal to B. From this, our target is to find out Y, because already L is known, B is given to us. So we will write from this line, that is 2 0 0 1 5 by 2 0 3 17 by 2 minus 69 by 5, along with y1 y2 y3 is equal to 8 15 8. Before proceeding further, I want to mention one thing, that this y1 y2 y3 are nothing but the components of y, and you may have one query that we are going to solve one system of linear equations and we are factorizing it in such a manner that we have to solve two system of linear equations, but immediately now you will feel the difference between this process with Gauss elimination method. Yes, we have to do some lines for Ax equal to B format, but here as we have distributed this in lower and upper triangular matrix, just by looking at the system we can find out the values, because we can write 2 into y1 plus 0 into y2 plus 0 into y3 equal to 8, which gives you 2y1 is equal to 8, which gives you y1 is equal to 4. From the second line you can write 1 into y1 plus 5 by 2 into y2 is equal to 15, and as y1 is already known to you, you have got the value, so you can write 5 by 2 y2 is equal to 15 minus 4, that is 11. So y2 is equal to 11 into 2 by 5, so you got y2 is equal to 22 by 5, and in the similar manner you get the value of y3, and y3 you got as 3. So y1 y2 y3 is now achieved by us, but it is not our final target. Our final target is to find out the value of x1 x2 x3. So now putting the values of y1 y2 y3 from the equation ux is equal to y, we get 1 minus 3 by 2 2 0 1 4 by 5 and 0 0 1 associated with x1 x2 and x3. Now look at this, the value of capital Y is known to us in the form of y1 y2 y3. We can write it as 4, then we can write it as 22 by 5 and 3, and here also just by looking at this structure and back substitution we get the value of x3 is equal to 3. Now putting the value of x3 in the second equation, we get x2 plus 4 by 5 x3 is equal to 22 by 5. So x2 is equal to 22 by 5 minus 4 by 5 into 3, that is 12 by 5. So what we get, x2 is equal to 10 by 5, that is 2. And similarly putting the value of x3 and x2 in the first part, we get the value of x1 is equal to 1. So this is my final answer, And before leaving this particular lecture, I just want to check that whether these 3 to 1 are going to satisfy my system of linear equations which is given to us. So you can put these values in all these 3 equations and you will get that all of them are satisfied. That means we have executed the A is equal to LU factorization method successfully. Just like the previous lecture, I will try to request you that you please factorize it. Already you have this factorization result if you have followed my instruction in the previous lecture, that you got different L, that is L dash and U dash, if you have considered the principal diagonal of L as 1 1 1 and the principal diagonal of U as U1 1, U2 2 and U2 3. In that case you get different L, different U. Use those two also. You will see that the intermediate results are different, but finally you are going to reach to the same destination. So nothing more for today's class. I just want to request you to follow these references and also solve this problem. Thank you. Happy listening. Happy learning.